We're going to start with modifying the Axon. So basically we need a paper tube that we can see into. So you're going to get this half sheet of paper and you're going to put your ruler down on the centimeter side and you can push it in almost the whole way. And you are going to mark at the 5 centimeter mark and the 22 centimeter mark. And then you are simply going to do the same thing on the other side. Turn the paper around. And again, you will mark at 5. And they should line up across from each other, 5 and 22. Okay, we're going to extend that line. And then we're going to cut. So we basically are going to get a like capital letter I. So I'm going to make a dashed line just so I can see where I'm cutting. And then you will cut out here, here, and down the dashed line between the 5 and the 22 centimeter mark. Boom, 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 boom. Okay, and then you'll do the same thing on the other side. And you can modify this as you go, but this is a pretty good start. And that's what your paper should look like. So now what we can do is we can roll this into a tube and tape these two ends, and then you will be able to see what's going on inside the tube. So a little piece of tape. Let's do it better than I'm doing it. It's nice and lined up. There we go. Take that end and we'll fold over and tape this end. So you've made the Axon tube. So you have an inside area. You have an inside area and you have an outside area. And then this is basically a cutaway so we can see outside and then we can see what's also going on inside the Axon. We're going to add positive ion channels to our Axon paper membrane. There are ions outside the Axon that need to come in. There are ions inside the Axon, and keep in mind, we need protein channels to allow ions to cross the membrane. To add the ion protein channels, we need to modify the tube. So you need a hole punch and you need a hot glue gun ready to go. So we're going to kind of do this in pairs. So I'm going to do a hole punch kind of two close together there. And then I'm going to put two more just a little further down the axon, and then two more here. Now keep in mind there'd be like hundreds of them surrounding this in a 3D fashion, but we're going to do just a small amount. Okay, so you need to take an entrance channel protein and pair it with an exit channel protein. And what I mean is they will be kind of side by side. These are a little too big for the hole punch. So to allow them to stay, you're going to take the glue gun and you're simply going to make a small circle of glue around there. It's okay if it gets in the hole because you're going to punch the channel protein through. So again, you want to leave that open, but that gives just enough kind of friction and texture that the protein channel will now stay. I'm kind of twisting it to pick up the glue as I push it through. So there we have an ion channel that allows positive ions to enter, and right next to it, an ion channel that lets positive ions exit. And then you're going to do that to the rest of the holes, this pairing. If you haven't already done so, you're going to have to carefully remove your axon from the cell body to allow for the new modified axon. Wow, this one is tough. I was on there tight. So now we just have dendrite, cell body. We need to add the axon with the ion channels to the cell body. To do that, you are going to take your scissors and you are simply going to cut 1, 2, 3, 4. And what that will allow you to do is to fold these down and have little tabs that will allow you to quickly place the modified axon onto your cell body. Okay, so it should look like this. And then you can simply use tape and you can tape on the new axon onto your cell body using the tabs. Grab the tape. 1, 2, 3, 4. Okay. And there you have your axon with the ion channels attached to the axon helix portion of the cell body. Should have a nice modified neuron with the axon showing the ion channels. We're now ready to use this model to better understand how an electrical signal is sent down the axon. So let's start with what the axon looks like when it's at rest, not sending a signal. You have all these different ions. Just going to move them up here. So inside the axon, there are many large negative ions. So we're just going to put a few of these large negative ions inside. So if you were to take a voltmeter and actually be able to physically put it in here, it would be a very negative reading because there's a lot of negative ions. There are negative ions also outside of the axon. They're a little smaller. So overall, inside is much more negative than outside. Now, to start, the axon at rest will have positive ions outside. Okay, so there's a few positives inside, but not very many. I'm just going to throw a couple in. So the overall charge at rest is the outside is positive because there are so many positive ions. Let's put a couple more out there just to show you the distribution. So many more positives out here than inside. So overall, outside the axon is positive and inside is negative. And you'll get an exact reading eventually, but right now just know it's negative inside, positive outside. For a neuron to send an electrical signal, there has to be a voltage difference. Right now, it's all positive out here and very negative in here. So to start a voltage difference, what's going to happen is some of these positive ions are going to be allowed to go through the entrance channel at the top part of the axon. Now they don't quite fit, so let's just pretend they're going to zoom in through the ion channel entrance protein. Okay, well, let's just look at this. These positive ions that were here are no longer here. They're inside the axon. If you were to take a voltmeter, you would see that this positive influx of ions increases the voltage. So inside this area of the axon becomes more positive, and outside, just where they are disappearing, this area becomes more negative. Now I have a voltage difference. That is an electrical signal. This is more positive because the positive ions went in, the voltage goes up, and outside now is more negative. So what happens is this influx of ions actually opens the next entrance channel. And now I get more positive ions coming in. And of course, that causes this area to be more positive and this area to be more negative. What's clever is it also triggers the exit channels to open. So all these ions that initially came in are drawn back out to the negative area. And so now the positives are back out. So now this area is positive, but this area is negative until, of course, the exit channel opens and the positives here can go back out. And this is all happening as the next set of ion channels open, allowing sodium or positive ions to enter, becoming negative until, of course, some of them exit. And it just keeps going the whole way down the axon like that. Enter, exit, enter, exit, enter, exit. And that makes the voltage change inside the axon. It will go up, and then as they leave, go down. And then the voltage will go up and down. And this continues the whole way until the electrical signal reaches the end of the axon. This graph shows the voltage inside of the axon, inside. So it starts at a -70 because it's very negative to begin with. As the positive ions enter, notice the voltage goes up. And as the positive ions exit, the voltage inside the axon goes back down. And this happens over and over as the signal propagates or moves down the axon.